Hello everyone, welcome to the second day of TestCon Europe 2022. This is the Quality Gems track. I'm Christina, your host, and now we start with the first talk after the amazing panel discussion we just listened to, where several ridiculous myths about testing careers have been busted but by our colleagues. So, the first talk is about the X factor. What is the thing that makes it or breaks it for software? Our speaker is Ron Werner. He's principal quality engineer in Kazoo, and he's been speaking at conferences for many years. He's the chairman of QA and Testing Bilbao. He's also part of the member, also part of the technical committee. His passion is testing, naturally, mobile testing, automation, AI, and he's been building successful automation frameworks for more than 15 years. And what I really loved in his description is that he has a clear, no nonsense view of what to test and what not to test, something that we sometimes miss. And one very important thing, he just got an Australian Shepherd dog. I want a picture. The talk, though, is about the history of software success and failures. He will take us on an expedition and he will show us whether there is a secret sauce that defines success in software industry and what role have testing played in the success story of awesome software. Ron, here you are.
Thank you, Christina, for the awesome introduction. Thanks a lot. So, quick disclaimer, there won't be any pictures of Australian Shepherds or dogs or cats. So I hope you can also see my presentation at the moment. I'm not sure if that works. Okay, here we go. So thanks for joining the session. We'll have a tour de force today. There's only 40 minutes, so we'll brush through a lot of history. We'll go back to the early beginnings, 40 years of software development, of successes and blunders, and then we'll finally discover, going through that, going all the way through today using AI and ML, and we'll start discovering what this is, at least in my perception, this mythical X factor that defines the success or the failure of products, which has to do with software testing, or maybe not. So let's see. So bear with me. I'd recommend have your mobile phone ready because it will be an interactive session. We'll have a video as well, and I will ask you to scan a QR code shortly because there will be a poll. So be ready for that. Open an extra browser window or yeah, get ready. So let's get started. So over the past couple of years, testing has gained a really bad reputation. So why do I think this is like this? Well, I guess the word testing has been associated quite a lot with this test harness or this test kit. So the COVID tests. So obviously everyone, also non-testing experts, they've been poking their noses into testing. And, you know, everyone's been hoping for tests getting green and not red, as you can see. So jokes aside, I don't want to play down the ferocity and the importance of COVID, but testing has been in everyone's on everyone's lips. So that can be a good thing. It can be a bad thing. But anyway, so as a tester, I'm not sure about you, but I've had the feeling that recently, you know, there's been a lot of demand and expectations on us testers. So as a typical tester, I brought you John Doe here. The expectation is that you're only 25 years old, but you have 20 years relevant work experience. You've been working in the relevant industry for over 30 years already. You know a multitude of programming languages. So you're proficient in Java, C#, Kotlin, Python, React Script, you name it. What? You never heard of React Script? Well, that's easy because it hasn't been invented yet. It doesn't matter, it's still a requirement. Furthermore, you should be active GitHub contributor in more than 5 different projects. You should have expert testing and working knowledge in 12 different other testing frameworks. And most importantly, you should have tested everything. That's always the question that puts a smile on my face when people ask, you know, oh, has everything been tested? So as a tester, you could, there's a multitude of questions that you can fire back at the question asker, but everything. Anyway, it puts a real smile on my face. So anyhow, I think over the past 40 years, this sentence has quite resonated with me. So less seems to be known about software testing than about any other software aspect of software development. And I'd like to have your opinion. There's a QR code here, and actually I have a Slido poll. So if you would like to join at slido.com or sly.do and enter the hashtag TestCon2022, and then we'll have your opinion. So there's different opinions here. So from you fully agree to you partially agree to you can't really say, over to you rather disagree or you fully disagree. So I'm waiting now for people to join. So far I can see, okay, one person joined, thank you. Special recognition. Someone fully agreed already. Let's wait for some more people. Don't be shy. It's going to be really interesting to see your opinion on this. So we have partial agreement, 6 people joined already, okay. Okay, so keep on joining and answering that question. I'm really interested in the results of this poll. So what I can see from now, it's partial to full agreement. And so thank you for this, for sure. So I'll stop right here. And I want to show you the results of the same poll that I did for different conferences. So at Testing United 2019, we have a matching picture. I asked the same question at Test Automation Days in 2020, where we have 75% of participants also partially agreeing. And only last month at Software Testing Conference BRX in Bratislava, there was also a major agreement on that. So where does this statement come from? It's actually, I didn't invent that. It's actually from a classic book of the software testing sphere. So it's The Art of Software Testing by Glenford J. Myers. That was the first ever book written purely on software testing, and it was published in 1979. And this is actually a comment from the sleeve of the book. So as you can see, things might not have changed over the past 40 plus years, it seems, but we'll dive into more details and explore. But to introduce myself a little bit more, so Christina already introduced me very nicely. Thank you very much. So as said, I'm working at Kazoo as principal quality engineer. I've been in the testing or quality industry for over 15 years, 18 years in IT. So a lot of time spent there. I'm married with one wife, 3 sons. We have 1 Australian Shepherd. I'd call myself Burrito vegan. So, you know, I like my meat and my burger every now and then. So I believe that 20% is enough. And I wanted to share the weirdest experience I had in testing, which is testing in Japanese. So you can see here, that's one of the dialogues where you're not sure when clicking on a button whether all the data that you entered actually goes to oblivion or it's actually stored. And I also wanted to share the first ever mobile phone, because in Japan, mind you, that's 20 years back when the Japanese were well advanced, and they had really small Keitais mobile phones with color cameras already, with color screens inside. And I want to share the first mobile phone ever. I'm an enthusiast for mobile testing that I got when returning to Europe. So I hope you're prepared. Here it is. Boom! It's an archaic Siemens C35 brick of a phone, so you'd have to wear safety shoes actually in case you drop it on your foot. Great, but jokes aside, let's dive back over 40 years into the year 79. So this was what home computers looked at that time. They looked more like typewriters. So at that time, we want to start with investigating successes in software and product development and failures. So let's dive straight into it. So the first success I want to share is the arcade game machine Asteroids. So probably you've heard of that. It's been a huge success for Atari. So the same thing happened to this machine that happened to Pong, like the grandfather of arcade game machines. You know, the first couple of machines, they didn't work anymore because the coin slots, they were blocked already because people had been pushing in so much coins, and it's been played quite a lot. So 70,000 units were sold. It was $150 million in sales by Atari, and a great share of revenue by the coin operators. So this was a huge success, and it was an innovation at the time to offer this video game in arcade halls. Let's talk about failures. In 2012, you might have heard of this one. So there was a company, Knight. I say that in the past tense because Knight doesn't exist anymore. Why? Because they had quite adventurous approaches to software development. And basically, they developed a software to help them with trading on the stock exchange, on Wall Street, actually. So because of quality deficiencies in their deployment and environment management processes, some engineer actually forgot that the code he prepared to test the system was actually deployed on a productive system. So within 45 minutes after market opening, there were wild transactions happening. And so randomly, $460 million were lost in this. And it took quite a long time. So that makes a case for monitoring and observability before this was actually discovered. And it was irreversible. So a lot of money lost in 2012. Let's talk about another recent success. So just today, actually, I think everyone here has used Zoom. So this is a company that was established in 2011. And, COVID helped in this case, really, because everyone went online, working from home, homeschooling, all of that. I think we all suffered from that. And then we come to enjoy that, actually. And one particular day in March 2022, that's just a brilliant indicator for the success. On one day, there were 2.13 million downloads of the app. That's unimaginable. The total revenue year to date, today actually, for the company is over 4 billion US dollars. Just let that sink in for a second. It's just crazy. So this has been a wild success, and it's successful over all their competitors. Another prominent failure was the Ariane 5 rocket launch in 1996. What happened here was that, so 47 seconds into the launch, actually, the rocket blew up. And what happened was that the software they used to control the predecessor, Ariane 4, was reused, which is good, reusing software. But basically now the problem was that these operators, there was a 16-bit integer that was now actually stuffed into a 64-bit variable. So what happened was there was a buffer overrun. So roughly 40 seconds after the launch, this measure that they took was actually about the velocity of the rocket. So at first it wasn't that fast, but when it went faster, they tried to stuff this 64-bit variable into the 16-bit integer. What happened? Well, there was a buffer overrun. The nose then just deep plunged and dived, so the rocket tilted. Then aerodynamic forces just ripped the rocket apart. And then after a split second, the self-destruction mechanism actually kicked in and the whole rocket exploded. That was probably, with $370 million lost, that was probably the most expensive fireworks display in history. Let's move on to another success. I think every one of us has it on their mobile phones, in their pockets. It's WhatsApp. So everyone's using it. You see everyone having that. Here's a sample picture of the tube where everyone is looking into their mobile phones. So this was sold to Facebook for $19 billion in 2014, and it's continuing to be a success. Another failure, again, where not just money was lost, but also a lot of lives, unfortunately, is the Boeing 747 MAX. So in 2018 and 2019, I'm pretty sure you recall. So the redundancy principle wasn't quite heeded by Boeing. So for safety critical systems, you should have two sensors. And in this case, there was only one sensor to actually again, measure the tilting of the nose to cater for different engine types that this airplane would be capable of carrying. And so if that sensor gave wrong information, the flight control went into an unrecoverable state. And so for normal, regular airline pilots, it would have been close to impossible to then still keep the airplane under control. So unfortunately, 2 planes had to crash before this was discovered. And yeah, that's a huge failure. A final piece, I wanted to show you now that chess is kind of in the media with the latest Netflix series, The Queen's Gambit. You might have seen it. It's really nice. And the current scandal about Carlsen and Niemann. About well, one calling the other fraud and big lawsuit happening at the moment. I want to go back to the year 1996, where there was the duel between Garry Kasparov, the acting world chess champion, and Deep Blue, that was IBM's supercomputer, the most powerful machine at the time. So I'll leave it up to you to judge whether this has been a success or a failure, but I'll tell you the story. So in this duel set up, basically, it was a chess game of 6 rounds. And the IBM engineers actually were allowed to tweak the algorithms between games. So they had a bit of an advantage to start with. So anyway, the Kasparov entered the first game and he rigorously won the first one. So all went well until the second game started. When opening, actually, Deep Blue then made a very peculiar, startling move. And Kasparov was getting nervous, so he was really flabbergasted, and that threw him off his guard, actually. And so he couldn't concentrate anymore. He lost that second set, actually. The following sets have been draws, but he also lost the final set. So that basically marked the start of an era when computers would beat humans, and especially in chess, that was a milestone. Now, this is a huge story, but afterwards, actually in 2012, there was an interview with one IBM engineer who revealed that what happened was actually due to a bug. So what happened at the beginning of restarting the second set, there was a buffer overrun which caused the default behavior for Deep Blue, which is to make a random move. And that really threw Kasparov so much off guard that he couldn't concentrate anymore and lost the rest of the sets. So this goes to show 2 things. Number one is software bugs are not necessarily always something bad. And the second thing is, this was probably the one and only time in history that a computer actually did something intelligent. Right, so let's discover, what is this, the mythical X factor in software testing deciding over success or failure? Let's investigate. So do you think it could be automation defining or deciding over success and failure? There are so many tools around, and I think you've probably heard a lot of talks about automation tools, how to use them, how to employ them, what's the best strategy of using them, and so on. And it's just, it's blowing your mind. It blew my mind 10 years ago when I attended the first ever software testing conference. It still blows my mind nowadays. My personal belief is that automation is a tool that helps you, but it doesn't decide over the success. You can agree or disagree with me, but bear with me. So from automation, let's move on to AI and ML. It's all over the shop, and I want to dive a little deeper into that topic. So does AI and ML decide over product successes or failures? So to give you a little background, there's a couple of voices here. Elon Musk himself, it's very funny. He says, oh, AI is highly likely to destroy humans. It's a fundamental existential risk for human civilization. Stephen Hawking chimes into this view. And you have some positive views as well. For example, Yuan-Qing Lin, I probably mispronounced his name. Sorry about that, but he's the former head of machine learning research at Baidu. And he claims, hey, there's good news. It's not scary. All of our work is getting complemented for the better. So we're not getting replaced. It's all good. And so chiming into this, I asked a while back at Oktoberfest, so the test bash held in Munich, I asked a sample of 50 different participants a few questions on using AI and ML. And I just briefly want to brush over the results. So my question was, I'm excited about the possibilities AI and ML offer in testing. Obviously, you see people rather agree on that. I asked the question, I found the outlook of AI and ML in testing rather scary. And you might see that 50% of people actually think, no, this is not the case. But, and that's remarkable, about a third of people answering the poll actually rather agreed on that. So there is an element here. I want to show you a little demo. So I asked Google Assistant. This is an AI tool. Everyone probably using Android has it in his or her pocket. And I asked, hey, Google, will AI kill the traditional mobile tester? I'm a mobile tester, so you'll see some references to mobile testing. So here's what they said. Hey, Ron, you're killing me with your questions. So I said, seriously, will it kill testers' jobs? The answer was, buddy, you're going to die anyway. Human mortality rate is still at 100%. So if you're smirking or smiling now, I think that's really funny. And if you're asking me, this would definitely pass the Turing test. The Turing test is a test that checks whether a person or a virtual person, which you don't see, is proclaimed to be a human being or a computer. So this would pass the test. And I want to ask you the question. A reality check in 2022. Do you think that Google Assistant really passes the Turing test? Is it yes or no? So you can type your answer in the chat, and then let's discover that. And no, it's actually a no. So this is set up. So sorry, I tricked you here. I want to show you the real results. So in 2018, 4 years back, I asked Google Assistant this question, and it came back with venturing, hey, I can search the web for answers. Well, that's not too intelligent. So I tried again. 1 year later, at least it would offer me the title of this talk that I did at a conference. So that's even better. And I just tried it recently, and it kind of understood the question and showed me some related videos about AI and testing. So that's quite good, and it goes in the right direction. Right, so let's move on. AI and ML in testing. You're probably aware of the distinction between testing and checking. So maybe to reiterate, testing is a very creative activity. So you establish outcomes which you don't know about before. It's an agile thing, it's exploratory, and it's collaborative. So it uses your intellect and brain. And basically, when doing exploratory testing, for example, you're building up your ideas and you're taking up smells as well as you go along. So you're creating your test strategy as you tag along. And you can use it to analyze risk as well. A check, on the other hand, is quite repetitive and dumb because that uses what you've learned from a test. So you know the inputs and you know the expected output. So whatever you do then is no longer to be considered a test. It's actually very static because you know the outcomes, it's scripted, and it kind of contains the risk. So it doesn't discover many new things, but it keeps the risk in check. And what I'd like to introduce you today is an extension to this, which I call the TCI cycle. It's a test, check, indicate cycle. It's not fully blown yet. It's an idea of mine that I stated, but basically in this additional cycle of indication. So it's additive, it provides intelligence, it derives new insights on risks, it indicates useful measures as well, and it helps you decide what to test or check and what not to test and check. And so all these extra insights, so you can take a look at historic commits, for example, code changes, bug history, smart suggestions, risk analysis. You can use observability. So it's all this kind of not shift left, but shift right initiative to learn from production data. So to learn what your users are actually doing on your system out there in the wild. And so as you can see, this dives back from indicate into the check, so you can update your checks, and it dives back into tests, so you can update the tests you're running to discover more risks, for example, and gain more information. So this also feeds back into the tests, and it feeds back into the indicate cycle. Right, so there are a number of tools out there already, and I just wanted to show you one example here. So this is one thing I tested. Let me play that video. So a few years back, this is the Twitter app. So I was writing to a friend, hi Toyer, this was a direct message in Twitter, and I actually twisted the mobile. I went to landscape mode and then back to portrait mode, and the text was gone. And this is quite a major bug. And I was wondering why this hadn't been discovered. So we'll dive back into that in a minute. So bear with me. But I want to go a bit further and show you what kind of tools we have at the moment. So ML and AI in testing, we'll just brush over this now, actually, but there's so many different tools out there. There's, I don't want to name them. You can read them on your own. But basically, thanks to Marcel Veselka, my friend who gave a talk on autonomous testing yesterday, maybe you've seen that. But he's actually got a GitHub repo where he's listing all the tools out there. So I put a link here. If you're interested, check it out. It's very useful. Common themes that I discovered with all these tools out there are that, it's kind of, no programming needed, low code. You have browser plugins, it's SaaS. You have these self-healing tests, then autonomous testing, hands off. You don't need to do anything more. In analogy to autonomous driving, you use dynamic locators for UI elements, better test coverage based on real production data. So using production insights. Improved accuracy, visual test case history, suggested failure, root causes with probabilities, and so on. So it's all common, but I think the scene and the software developers have advanced. But what I discovered, here's a example that I want to show you. It's 2 years back, but anyway, what I discovered is mind the gap. So there's a discrepancy in the actual marketing claims of most of the tools, I would say, and what they really can do for you. And here's one example I want to present. So one of these, companies actually, they offered me a report on the future of quality, an infographic. Okay, so wouldn't you be interested in the future of quality? I certainly was. And so to get this report, you'd have to fill in a number of things, and then you would get sent the PDF or whatever. So being a tester, what I did first time was basically not filling in anything in these required fields and then hitting send. And what happened then was that you can see that here, the layout was twisted. So that wasn't that great. But the major thing was their conversion rate was completely broken, because on this browser, on Chrome actually, I was not able to scroll down all the way because of these error messages that popped up. So I was not able to finish this form to get the report. So I would have to reload the page to start from the beginning. And I think that's quite poor for a company that claims to have, UI capabilities using AI and ML for testing. They should eat their own dog food. Anyway, I asked testing experts all around the globe about their opinion on AI and ML in testing. And Christina, if you are so kind as to play the video I prepared, then I want to share the results with you.
Knowing what I know now about ML, I think there is a lot more potential into analyzing source code via ML and looking for models and even feeding it information from bugs, from contributors, et cetera, all the things that contribute to risk, and building a very nice prediction engine around which areas of the software are more risky for change, which areas would need more testing, and maybe even generate those tests right away to help alleviate or prove that risk. Down the road, I want to see machine learning that analyzes code, that writes some of our code for us, that looks at customer usage patterns, looks at all the different data sources we have, and helps us figure out, doesn't replace what we do, but it helps target us, figure out what we can do.
And to me, that's the huge power of it. Our test environments never will look like production. We can never know everything users will do in production. So having tools that help us much more easily and quickly learn from production. Either we could even learn about, maybe people are going to a certain point and abandoning. So maybe there's a feature that's missing, or maybe there's something that's just not discoverable. So we can learn so much with the help of these types of tools.
Build it. What I would like to see is a tool that really supports me as a tester. So I want it to observe what I'm up to and suggest heuristics to me. I want it to fire bug reports at me based on what it thinks I'm up to. Or, you mentioned looking at Git logs. I want it to analyze Git logs and tell me where it thinks is going to be a challenging part of the system. I want it to pull down analytics from whatever system we're using to tell me how much risk is associated with this area. I want it to do the log analysis like you mentioned, show me the crashes. I want it to scan all my historic testing notes to try and make recommendations to me, because even though I am a skilled exploratory tester, I can't remember everything. And I told you this recently, but and also I want to wrap it into like a virtual reality world or an AR world, where I've got some sort of headset on and I can look around and I can see recent bugs up here, and I can see commits over here. That would be submerge myself in this testing world with my AI testing friend. That's what I would like to see.
I would like to see AI for me as a tool, as an additional tool for me as a tester, to use it in my toolbox. So for example, if I test in some simple input, so I just enter some data, but the machine could just tell me, hey Daniel, please also enter different Unicode characters, or have you thought about testing different languages, or you check now an input field, but rather test also the API underneath. So just give you some guidance of stuff that you have not in your current mind and not in your current focus, but the machine knows that it's like a complex system behind. And I think that's the way to go, or at least I hope that's the way to go.
Every application is going to be different in some kind of way. This is where us as specialists come in, where we can come and provide that domain expertise. So we get all of the nitty-gritty things out of the way, the common stuff, and then we hone in on what's really special about our apps.
Thank you very much. Can we go back to the slide deck, please, Christina? Thank you. So you've heard the testing experts. You might have known or met one of these ladies and gentlemen. So as you can see, as Richard mentioned, to go into the nitty-gritty of software testing, to get down to it, as Angie Jones mentioned, Richard actually mentioned something that I really liked, an idea that you have some kind of AR goggle set that helps you while testing, like a testing assistant. And I want to share with you some ideas of where I see chances for AI, specifically in mobile testing. So we have the problem space with, the usual fragmentation, lots of different devices and resolutions out there. Which test devices should you select? You need early feedback, access to real devices. That's still a problem. The automation tools are rather brittle. It's UI automation. The mobile experience needs to be checked, usability testing and API testing. So a lot of problems, but there's a solution space. So in the solution space, you could have machine learning, for example, for an automatic device proposal, deriving that from the logs and your user data. You can use machine learning on code. So nowadays you have GitHub Pilot, for example. There's another solution, source.tech, for example, that analyzes your code base and gives you recommendations even before the code is getting merged. So it's very clever, and so we can use machine learning techniques in a sensible way. You can access real devices as well, because that's what mobile testing is about. You need to really have a real device and not just test on simulators or emulators. You can cover standard situations. You have learning IDEs, for example, to help you when coding. Use smart logs, fuzz testing, derive behavior from logs, and so on. And have smart API tests as well using machine learning. So solutions exist already in parts, and I wanted to present you one interesting thing. So this is the example I showed before, where I was actually testing the Twitter app. I wasn't testing it, I was actually a real end user. And so what I envision is what Rich Bradshaw came up with, kind of this AR goggle set that I can put on while doing my exploratory testing. That helps me. So actually, while testing, I'm getting live data. For example, the AI assistant tells me, hey, I'm screening the logs as you test along. There have been 3 related exceptions since you started your exploratory test session. Wow, that's useful. Or, wow, this just appeared to be a bug, and so far nothing similar has been reported in Jira yet for build XYZ. Would you like me to create a Jira issue, including reproductive steps and a video replay of the last 60 seconds? Absolutely. I don't want to do all of that stuff. I'd love to have an ML assistant doing that for me. The code coverage is now at 34.8%. Keep testing at the current rate. You'll reach 50% by 11:24 a.m. today. Wow, that'd be really good, like a live code coverage indication as I test along. Or you might want to try the landscape portrait change and the profile location screen. There has been a 12% increase of user crashes over the past 2 weeks. Would you like more information? Yes, I do. Absolutely. Wouldn't you? And to be absolutely perfect, the assistant would tell me if my coffee is getting cold and reminds me that there's a life outside of software testing as well. So my vision is to have AI as a testing buddy. So like climbing, you have your rope partner, you have somebody who you can trust, who helps you and who helps you reach a certain goal. So to summarize, I think what's important is to use this testing buddy analogy to have an AI that learns with each mob testing session, mob coding session as well that you do. That's me with some former teammates. AI helping shifting quality left and right as well. So looking at observability metrics, for example. And AI becoming part of the test cycle and becoming yet another tool in your tool belt. So, but let's get back to the actual question. Is this really the X factor in software testing, deciding over success or failure? I'm not sure. I believe success is rather defined by innovation. But it needs to be innovation. As you could see, for asteroids, for example, Zoom and WhatsApp, they all have been successful. But it needs to be innovation with the right timing. And there's other examples as well. You might recall, if you're younger than me, then chances are low, but you might recall the Laserdisc. This was like the predecessor of the CD. It was huge, like a record, but it failed miserably because the technology was too expensive. Players were super expensive, so that failed. And the successor, actually, the CDs, they became wildly popular. Another example is the Palm Pilot. If you've ever seen these, or the Pocket PC by HP, for example, I wrote my master thesis using one of these HP Pocket PCs 20 years back. And then I really loved these devices. You'd have your input pen, they were quite simple to use. But for some reason, then the mobile phones came out as well. And this kind of personal assistant was not that popular anymore. So they basically vanished from the market. The third one down here are the Maelstrom glasses by Sony, or Google glasses by Google. And when they first came out, they had the same problem. They were too far ahead of the competition. So it was the first time that they released them. And basically it was, way too advanced. Nowadays, Google is actually reissuing them for businesses. And I think they're fairly successful with this. So innovation is hard. As you can see from another example, it's Apple. When they first released the EarPods, they were the laughing stock of the market. There were fun memes out there, claiming in 2016, first they're taking away the wires, then they become smaller and smaller. And at the end of the day, they thought, okay, 4 years in the future, then, you'd pay a lot of money for nothing. There was also the joke that people would keep losing them, so you'd have to buy new ones, earning Apple more revenue. There was another joke, the new AirPods by Oral-B, so putting your toothbrush extension in there, and it was really, really funny. So one Twitter user tweeted after the Apple event, "If only there was an invention that could keep those AirPods tethered together like a string." So it was really funny, but basically they stayed on topic. They released more versions, and this is the current AirPods Pro version. Actually, they look a little bit like a miniature version of a blow dryer, of a hair dryer. But when you recall last time in public transport, everyone's wearing these things, right? Or at least some that look very similar to AirPods. So now, in the final minutes, I want to share with you what, in my opinion, is success. Success to me is defined only by one person, by the user. And that's the simple truth, the simple secret that I wanted to share with you today. So who is this sharded user, this mysterious person? Let's unveil the user and take a look at one example. I brought one example from my previous employer, Join. It's a video streaming company focused on the German-speaking market. And here you can see, so we have players for all mobile devices, for smart TVs, for web as well. And here we managed to actually bring up the popularity of the mobile apps but from 3.4 to 3.6% in only 4 months at the time, with a lot of user ratings as well. And the way we actually did this was by involving the user. So there was, of course, exploratory testing, automation and test. We did crowd testing, A/B testing, stage rollouts, bug bashes, user experience research. But we used, shift right, so monitoring and observability tools, analytics, AppFollow, Instabug, Fabric, Trustpilot as well, to know what the users are doing. And we started community building. So listening to the users, responding to the users, and in total, basically incorporating feedback we received from the users. So that's really important. And I want to close with 3 main pillars that I think are important to be able to focus on the most important thing for your product success. First thing is you have to refocus on the user. So customer obsession is one of Amazon's key principles. Although I think that obsession can also have a negative twang to it, but I think you get what I mean. It's really, if you put the customer first, then you're on a very good trajectory. So this is what we did, not only at Kazoo at the moment, but also at my previous company, Join. So we did some community building. We started listening to the users, looking into Trustpilot reviews. We responded to the users. We did intense UX research, and we incorporated the feedback into the product. The second pillar is let tools assist you, not lead you. So here's a nice quote I found by Glenford Myers. You remember the author of The Art of Software Testing. A good test case is a test case that has a high probability of detecting an undiscovered error, not a test case that shows that the program works correctly. So you see, a fool with a tool is still a fool with a tool. So use those tools, well, as what they are, a tool, and not let them guide you through the whole process. The third and final pillar I wanted to share with you is you should begin with the end in mind. That's a very famous saying, and I have a couple of more quotations here. So the World Quality Reports over the past years, their top priority is ensuring end user satisfaction and customer experience. One of the modern testing principles is by Alan Page, who you saw earlier in the video, and Brent Jensen. We believe that the customer is the only one capable to judge and evaluate the quality of our product. I think they're damn right. Delphi Jim Myers again, he states, we try to solve the problem of bad software by rushing through the design process so that enough time is left at the end of the project to uncover the errors that were made because we rushed through the design process. So he also claims shift left and start early, involve the customers. And finally, management guru Peter Drucker, in his book in 1974, actually, he said, efficiency is concerned with doing things right. Effectiveness is doing the right things. And that might resonate with you, building the right thing over building the thing right. And so I want to tweak this headline here and say, begin with the end user in mind. And that's how I want to close and say thank you to all of you. But I would also like to extend my thanks to Richard Bradshaw, Angie Jones, Daniel Knott, Lisa Chrisman, and Alan Page, who actually featured in the interviews that I showed. Great, and I think we can dive into questions.
Thank you so much, Ron. It was very inspiring. There was a lot of food for thought for me, at least. Thank you for the assembly of all the tools that you're using and how you've used them and what made your project successful. There's a lot we learned. There are no questions though, so we're right on time. I think you've explained it so well and so clear. People would just like to let it sink in.
Okay, great. Yeah. So unless you have a question, Christina.
I need to have it thinking as well. I want to jump
Okay.
in and start looking for the tools to looking into the repository you shared. I also shared it in the chat.
Yeah.
Um, there's a lot to explore. So
Okay.
everyone follow Ron. He's very active on Twitter. Follow him.
Yes,
There's
please.
so much we can keep learning from Ron. Thank you, Ron. One
Okay.
question. When machine learning should be included into the project?
When? Well, it's a very good question. So I think machine learning can only ever excel when you fed it with a lot of training data. So you've gone through a lot of cycles. So that means whatever AI claims, ML claims tool you'll use, immediately you might get like the results that have been reaped before. For example, there are AI tools or ML tools that help you automate the testing of a login screen. Yeah, but what that does, it's not testing, it's checking. You kind of have the expected inputs, the expected outputs. So it's a very standard situation. So then the tool will help you, but you don't need AI for that, to be honest with you. So I would suggest the earlier you involve ML, the earlier you can start reaping the harvest and really getting results from the data that it consumed. So reading log files, analyzing user behavior, checking the success of different feature variations when doing A/B deployments, for example, and so forth. So I guess involving it early, that's my suggestion. But just be patient because you might have to wait a bit until you can actually reap the results.
Start collecting the data first, right?
Yes, exactly. And I have to say, I don't recall who said that, but a lot of the data scientists actually, they are brilliant testers because they know exactly with the amount of data they have, they are running experiments, they're running hypotheses that they have to prove or refute, and they've become really, really excellent testers. So if you have a data scientist in your company, go grab them for a coffee or invite them for lunch. You can learn a lot, and I think vice versa.
And we have one more question from Sayora. Do you really think such an AI to all that will be there soon?
I think producers are catching up, but to do all of that, to fulfill all the claims satisfactorily, my honest opinion is that's never going to happen because at the end of the day, software products are made for real human beings and for users out there. And how would a machine learning algorithm ever learn whether a new feature that it has no idea about will be successful or not? I think that part, this inventive ideation creation part, and that still belongs in the human sphere and the human mindset. But I think the evaluation of the results, then, I'm pretty sure we can use ML as one more tool, basically, to help us and to get rid of the nitty gritty that Angie Jones, as she called it. So all the chores, the boring tasks, leave it to tools like ML, for example.
Thank you, Ron. Thank you, everyone, and see you in the next session. Bye.
Thank you very much for having me. Bye-bye.